Okay, so for part 2 of section 4.1, let's recall. So for all real numbers A, so notice what I say versus what I write. For all real numbers A, so for all A is an element of the real numbers. Read aloud for all real numbers A. This implies that A times a function f of x stretches the graph of f of x. So stretches the graph of f of x by a factor of A vertically. So by a factor of A vertically. So it stretches it vertically. So say if A were 5, it would be 5 times as tall. If A were 1/2, it'd be half as tall. So for example, so let's go ahead and plot f of theta is, 3 sine of theta. So once again, we're going to put our theta versus f of theta coordinate axes. I'm always going to have 4 quadrants to the right and 4 quadrants to the left. Remember, our domain is theta, not x anymore. So we'll call this f of theta here. Let's do 1, 2, 3, 4 quadrants to the right. 1, 2, 3, 4 quadrants to the left. Let's do 1, 2, 3, 1, 2, 3. So the reason I'm going up to 3 and down to -3 is because of this 3. I'm going to stretch my graph vertically by a factor of 3. So my first quadrant, well, I start at 0, then pi over 2, pi, 3 pi over 2, and 2 pi going forward. Then minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi going to the left, minus 2 pi period. Okay, so I know sine would normally sine starts at 0, right? And then goes uphill to 1, back down to 0, down to -1. Okay, so sine starts at 0, goes uphill to 1, back down to 0, down to -1, and back to 0, and in the opposite direction, going backwards. So if I were just going to plot sine, this is what I would plot. And remember, this does go on forever. To the right and to the left, the domain is infinite. However, so this is just sine of theta here. I'm now going to stretch each point vertically by a factor of 3. So 0 times 3 is still 0. 1 times 3, however, is 3. 0 times 3 is still 0. -1 times 3 is -3. And 0 times 3 is 3. Similarly, going to the left, -1 times 3 is -3. 0 times 3 is 0. 1 times 3 is +3. And 0 times 3 is 0. So I get this nice sinusoidal graph that's stretched vertically by a factor of 3, meaning it's 3 times as tall because of that 3 in front. Let's see if I can draw this. I can. Maybe not well, but I will try. Okay, well, that's supposed to be smooth there. Okay, so notice it's still a sinusoidal graph. However, it's stretched vertically by a factor of 3. Okay, so that's what the 3 does in this case. It stretches the graph vertically. So this is this is 3 sine of theta. 3 times as tall. Okay, let's do another one, maybe with cosine. So for example, So let's plot the graph. Plot the graph of f of theta being equal to, say, now 2 cosine theta. Okay, so theta versus f of theta coordinate axes. My domain, or my horizontal axis, is theta. So I have f of theta here. Let's do 1, 2, 3, 4 quadrants going to the right. 1, 2, 3, 4 quadrants going to the left. Now we're going up to a stretching factor of 2. So we start at 0, then pi over 2, pi, 3 pi over 2, and 2 pi going to the right. Or negative pi over 2, negative pi, negative 3 pi over 2, or negative 2 pi going to the left. Okay, so cosine, where does cosine start usually? Let's look at cosine. Cosine usually starts at 1, goes down to 0, down to negative 1, and is symmetric with respect to the y-axis. So I know cosine would normally start at 1, go down to 0 on either side, down to negative 1 on either side, back to 0, and then back to 1 where it began. So normally, cosine would be this nice sinusoidal graph looking something like so. Okay, however, we're going to plot 2 cosine of theta, which means I multiply everything by 2. What's 2 times 1? It's 2. What's 0 times 2? It's 0. What's a negative 1 times 2? It's negative 2. What's 0 times 2? It's 0. And 1 times 2 is 2. Going to the left, 0 times 2 is 0. Negative 1 times 2 is negative 2. 0 times 2 is 0. And positive 1 times 2 is 2. So what we get then, let's see if I can draw this, is this nice stretched out, I can try and draw this, stretched out graph. Looks something like so. No, it's supposed to be smooth, but it's kind of hard drawing this by hand. But hopefully you can see what I'm trying to do. I'm just trying to stretch this graph vertically by a factor of 2, making it twice as tall. Okay, so this would be 2 cosine of theta, whereas the gray guy was just cosine of theta before I stretched him vertically by a factor of 2. Okay, so now let's recall. Hopefully that makes sense. Let's recall now translations across axes. So recall that negative f of x reflects the graph of f of x, reflects the graph of f of x about the, well, let's think about this. F of x is my y-coordinate. If all of my y-coordinates are now negative, what was once positive is negative and vice versa. So that means it reflects the graph of f of x about the x-axis, the horizontal axis. Okay. So for example, let's plot the graph of f of theta is negative 2 sine theta. Okay, so now I have a couple things going on here. So let's see theta versus f of theta coordinate axes. Horizontal axis is my domain, theta. Let's account for 1, 2, 3, 4 quadrants to the right, and 1, 2, where am I? 3, 4 quadrants to the left. We're going up to we're going up to a height of 2. So we start at 0, pi over 2, pi, 3 pi over 2, 2 pi. And backwards, minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi. And 1 and 2 up, and negative 1 and negative 2 down. So sine normally starts at 0. We go up to amplitude, back down to 0, down to negative amplitude, and up. So the normal sine, if I were to just draw sine, would be something like so. Sine always goes through 0. So this is what sine would look like. So this is just sine of theta. However, now I'm multiplying each of these points by negative 2. So now I'm going to multiply everything by negative 2. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Negative 2 times negative 1 is positive 2. And negative 2 times 0 is 0. Going backwards, negative 2 times negative 1 is positive 2. Negative 2 times 0 is 0. Negative 2 times positive 1 is negative 2. And negative 2 times 0 is 0. So we get not only that it's twice as tall, stretched vertically by a factor of 2, but we'll notice it's also a reflection about the x-axis, right? It's going in the opposite direction. Where it used to go down, it goes up, and vice versa. Because it's been reflected about the x-axis. And this graph is not looking as nice as I'd like it. Needless to say, there are no points on the graph. It's all nice and smooth. It's a nice, lovely sinusoidal graph. Okay, so this graph is negative 2 sine theta. Not only is it going up when it should go down, but it's twice as tall. Okay, let's do another one with cosine. So for example, let's plot the graph. Let's do f of theta is, I don't know, negative, what the heck, I'll do 3. Negative 3 cosine theta. Do I have enough room? I don't. That's why maybe I shouldn't do 3. Let's do negative 1 or 3/4. Let's do 3/4. Okay. So, once again, we have a horizontal axis and vertical axes. I'm going to be changing. So let's see if this is 1, and this is negative 1 down here. So let's do 1, 2, 3, 4 quadrants to the right, and 1, 2, 3, 4 quadrants to the left. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so normally cosine would start at amplitude 1, go back down to 0, down to negative 1, and back up to 0, and is symmetric with respect to the y-axis. So normally cosine would look like so. Well, okay, having issues drawing this. So So this is before I multiply by that negative 3/4. So what will that negative 3/4 do? Well, I claim the negative will flip it upside down, but I claim the 3/4 will make it 3/4 the size, meaning vertically. So this would be normal cosine of theta. But now I'm going to multiply each of these by negative 3/4. So 1 times negative 3/4 is negative 3/4. 0 times anything is 0. Negative 1 times negative 3/4 is positive 3/4. 0 times anything is 0. Positive 1 times negative 3/4 is negative 3/4. 0 times anything is 0. Negative 1 times negative 3/4 is positive 3/4. 0 times anything is 0. And a negative 3/4 times positive 1 is negative 3/4. So what do we get here? Let's see. So let me try and draw this. So we're going to get a graph that is 3/4 the height of the original graph. 3/4 is tall, but is also going in the opposite direction. So where the normal graph went upwards, this graph is going down, and vice versa. So it's been reflected about the x-axis, and it's being smushed by a factor of 3/4. It's only 3/4 the height it once was. Okay, so hopefully that is making sense. I'm not going to stop the video here. Let's continue. So what else should we recall? What other types of translations? Let's do horizontal. So let's recall. So we've stretched things vertically. Now let's stretch them horizontally. So f of the quantity a times x contracts the graph of f of x. The graph of f of x by a factor of a, and this would be horizontally, factor of a horizontally. Okay, so for example, let's plot the graph. So plot, and let's make things simple to start off with. Pardon me. F of theta, let's do is sine of 3 theta. Okay, so I'm still going to, well, let me note something. So note, contract by a factor of 3, right? Contract by 3. Or let me write a factor of 3. Okay, so x and y, or theta versus f of theta coordinate axes. So nothing changes vertically this time. Now it's going to change horizontally. So theta versus f of theta. So we have 1, 2, 3, 4 quadrants. Actually, let me make them a bit larger this time so I have more room. 1, 2, 3, 4. Then 1, 2, 3. Oh, I don't have enough room going that way. 4. Okay. So normally we would have 0, pi over 2, pi, 3 pi over 2, and 2 pi. However, we're contracting by a factor of 3. So what this means is I have to divide everything by 3. It's now 3 times as smushed. So I divide everything by 3 because it's horizontally 3 times contracted. So going backwards, what does this yield? So this would be negative, instead of pi over 2, it's pi over 2 times 3. So that's negative pi over 6. And instead of negative pi, it's negative pi divided by 3. Instead of negative 3 pi over 2, the 3's reduce, and I'm left with negative pi over 2. And finally, instead of negative 2 pi, I divide by 3, so negative 2 pi over 3. So this is now the contracted horizontally graph. Once again, I still have 1 and negative 1 as my height. Since it's sine, I start at 0, and I go up to amplitude, back down to 0. I meant, well, not amplitude, we don't know that word yet, sorry. Go up to a height of 1, back down to 0, to negative 1, then back to 0, and vice versa, going to the left, negative 1, 0. Oh boy, did I mess up? I messed up with my spacing, didn't I? Shoot, this should have been further to the left. So I really don't have room, do I? Oh, well, I messed this up quite well, didn't I? 1, 2, 3, 4. Yep, I messed this one up royally. Okay, good job. By which I mean terrible job for me. Sorry, this should be over one more. Okay. Where was I? Trying to plot sine. Okay. So, everything looks the same. It's like I haven't changed a thing. The only thing I've changed is how I name the tick marks on the x-axis. I name them by dividing each one of them by 3. I'm contracting horizontally by a factor of 3. So you'll notice everything looks identical. But your tick marks have to be changed as far as what they're called. So this is how we contract horizontally. So let's do another one. So for example, let's kick it up a notch, shall we? Let's plot f of theta is cosine of 5 theta. Okay, so this time I'm going to contract by a factor of 5, right? Note, contracts by a factor of 5. Factor of 5. So what does that mean? That means I'm going to divide each of my horizontal tick marks by 5. So here we go, theta versus f of theta coordinate axes. Maybe I'll move over a bit, or maybe I'll just use 3 instead of 4 in between my tick marks. That might be better. Okay, here's theta. So 1, 2, 3, 4 quadrants to the right, 1, 2, 3, 4 quadrants to the left, and here's my f of theta axis, 1 and negative 1. So usually I would have pi over 2, pi, 3 pi over 2, and 2 pi. However, because I'm contracting by a factor of 5, I divide everything by 5, because now it's 1/5 the normal horizontal breadth, if you will. Okay, to the left, instead of pi over 2, it's now pi over 2 times 5, so negative pi over 10. To the left, instead of negative pi, it's negative pi divided by 5. Once again, instead of negative 3 pi over 2, it's now negative 3 pi over 2 times 5, or 10. And finally, negative 2 pi over 5. Those are my new contracted points. Okay, cosine starts at amplitude and goes down on either side. Sorry, I keep on using the word amplitude that we don't know yet. Height starts at the height of 1 and then goes down to 0. Okay, and it's symmetric with respect to the y-axis. So it looks something like so. So notice it's going to be the regular graph of cosine. The only difference with this graph are the tick marks, right? The values of the x-coordinate tick marks, and that is it. Let's kind of nice to have a chalkboard that I can move around. Okay, so there we are. Not drawn incredibly well. This is terrible here. Let's see, maybe I can draw this a bit better. Okay, so this would be cosine of 5 theta. The only difference being the values of the tick marks. Okay, so definition. Let's see, do I have room? Yeah, definition. So let's let A and N be real numbers. Then, for either, let's say f of theta is equal to A times sine of N times theta, or f of theta is equal to A times cosine of N times theta. Number 1, A is the amplitude or maximum distance from the x-axis. So A, whatever's in front of the trigonometric function, sine or cosine, is the amplitude. And 2, P, the period, is given by, so we've already defined period before. And normally the period for sine and cosine is 2 pi, but now it's given by 2 pi divided by n, much like I divided everything by n over here, right? Whatever the coefficient was. Okay, so let's use this in an example. So, actually, let's note, why is that? So note if how do I want to say this? Theta is 2 pi over n, then cosine of n theta, or sine of n theta, is equal to, yields, so cosine, why can I not draw a 0 or an O? Cosine of n times theta will be cosine of n times the fraction 2 pi over n for theta. Notice that the n's reduce, and we get cosine of 2 pi, which is 1 full period, right? So notice that if theta is 2 pi over n, that yields the period, and that's where we get that from. Okay, so where was I? Back to our regularly scheduled program. So for example, so let's find the period and amplitude and then plot. So find the period P, amplitude A, and then plot the following functions. Okay, so number 1, let's say we have that f of theta, that's a terrible theta, let's see, f of theta is going to be 3 times sine of 7 theta. Say. Okay, so I claim that the amplitude A is the 3 attached, right? That's the number attached, the amplitude A. So 3 times as tall, right? Now, I know that N is 7, but that's not the period. So the period is 2 pi divided by N. So that's going to be 2 pi over 7. Okay, so let's use this and go ahead and plot. So we have theta versus f of theta coordinate axes. Let's see, hopefully I will have enough room. I'm trying to plot this with that analysis there. Maybe I should have done something else, but let's see. So 1, 2, 3, 1, 2, 3, almost. Okay, so let's do 1, 2, 3, 4 quadrants to the right, 1, 2, 3, 4 quadrants to the left. So 0, pi over 2 normally, pi normally, 3 pi over 2 normally, and 2 pi normally. However, we are dividing these by the coefficient in front, namely the amplitude. So I divide each of these by 3. So going to the left, that would give me negative pi over 2 times 3 is 6. Negative pi divided by 3. Then the 3's reduce, so negative 3 pi over 2 divided by 3 reduces to negative pi over 2. And finally, negative 2 pi over 3. Oops, why did I do that? That was the amplitude. Wrong number. Sorry. It's dividing by the amplitude, not by the horizontal factor there. Amplitude is height. How far away from the x-axis I am. So that would be 1, 2, 3 vertically, negative 1, negative 2, negative 3 vertically. So that's what I get for jumping the gun. N is 7, so I divide by 7 because that's inside the function. So now I'm dividing by 7. Sorry about that. Once I defined it formally, clearly I could do it up here, but yeah, anyways. Okay, so let's get this right now, by which I mean me. So going to the left now, dividing by the 7 that's inside the function, this now becomes negative pi over 2 times 7 is 14. This now becomes negative pi over 7. This now becomes negative 3 pi over 14. And finally, negative 2 pi over 7. And notice that the period is 2 pi over 7, which is what we have for 4 quadrants. Okay, let's see if I can actually plot this now. So sine starts at 0, goes up to height, goes back down to 0, down to negative height, or amplitude, back to 0. So now I can use the term amplitude, and I'm just going to plot the ones I can fit on this graph. So we have a nice sinusoidal graph that is 3 times as tall because of the amplitude. So he's been stretched vertically by a factor of 3. But because of that 7 inside the function next to the theta, that is what changes our tick marks on the x-axis, or horizontal axis rather, to be divided by 7, each of them. Okay, so I think I'm going to not have enough room after this, so I'll just put an arrow. So there we are. So this would be, let me color coded, amplitude 3. This is sine of 7 times theta. So the 7 contracts horizontally, the 3 stretches vertically. So let's see if I can actually handle another one. So number 2, let's say we have that f of theta is, let's do 2. I don't like them being that tall. Cosine of what should we do? 8 theta? That sounds good. Okay, so now the amplitude is 2, and that's a vertical stretching factor. The number attached to theta inside is 8, which means that the period is going to be 2 pi divided by 8. So 2 pi divided by 8. Well, 2 goes into both 2 and 8. 2 goes into 8 4 times. So now the period is pi over 4, and let's see if that works out. So theta versus f of theta coordinate axes. Maybe I'll start down here. I know I only have an amplitude of 2, so it doesn't need to be that vertically inclined. So theta and f of theta. My amplitude goes up 1, 2, and down -1, -2. So let's do this 1, 2, -1, -2. My quadrants 1, 2, 3, 4 quadrants to the right, 1, 2, 3, 4 quadrants to the left. Normally, I would have pi over 2, then pi, then 3 pi over 2, and then 2 pi. However, what am I dividing by? Let me make sure I get it right. In this case, I'm dividing by 8, so everything's going to be divided by 8. Let's divide all of these by 8. Contract it by a factor of 8 horizontally. So now going left, I will have negative pi over 2 times 8 is 16. Then negative pi divided by 8. Then negative 3 pi over 2 times 8 is 16. And lo and behold, 2 pi over 8 reduces to negative pi over 4. So yes, my period is indeed pi over 4. So cosine starts at amplitude or height, goes down to 0, down to negative amplitude, back up to 0, back up to amplitude or height. So cosine, remember, is a mirror image on either side of the y-axis. So we can think of the y-axis as a mirror for cosine. And there are no points, so you try and make this smoother. Smooth. These are nice, smooth sinusoidal curves. There are no points on them, even if I can't draw them well. Okay. Oops, no, that's not what I wanted to do. Okay, so there we are. So let's write this out. We have an amplitude of 2. The function here is cosine. The coefficient of theta was 8. So 8 times theta. Okay, so that's a graph there. Now let's go backwards. I'll give you the graph and you tell me what the function is. Do I have enough room? Do I have enough room to put one on there? Maybe if I move up a bit. Okay, I'll move this question up a couple, see if I can force. Why does that say 0 axis instead of theta? Okay, so let me change this. This is not the 0 axis, it's the theta axis. Okay, so now. So example. This next example will be find a formula given the following graphs. So find the formula for the following graphs. So number 1, let's say I give you theta versus f of theta coordinate axes. Oops, come on. I want this to autocorrect. There we go. Okay, perfect. Theta versus f of theta. let's do 1, 2, 3, 4 tick marks. 1, 2, 3, 4 tick marks. Okay, let's have these be pi over 10, pi over 5, 3 pi over 10, 2 pi over 5, negative pi over 10, negative pi over 5, negative 3 pi over 10, negative 2 pi over 5. Okay. 2 and negative 2. Okay, so let's say we have a graph that looks something like so. Nice, lovely. Well, if I could draw it, it would be lovely. Imagine, if you will, there are no ugly points here, and it's a nice, lovely sinusoidal graph of some sort, either sine or cosine. Okay, so let's look at this. So what is the amplitude here? Do I know the amplitude? Yes, I know the amplitude is 2. Do I know n, the number that I divide 2 pi by to get the period? Well, that looks like it's 2 pi over 5. So I claim that n is 5 because I'm dividing by 2 pi right there. And since this goes from 0 uphill, I claim that this is sine. It's a sine. So therefore, these together give me a formula of amplitude 2 sine of coefficient that I divide theta by, 2 pi by. So 5 times theta. So I claim that that is the formula here. The height is 2, and I've divided my horizontal components by 5. Okay, let's do another one. And sine starts at 0 and goes up. So number 2. Let's say I give you the following graph. Theta versus f of theta coordinate axes. Wow, that is not a straight line. Let's see. So theta versus f of theta. Let's do 1, 2, 3, 4 quadrants. 1, 2, 3, 4 quadrants. So we have 3, negative 3. What color should I use for those? Okay, so let's say we have pi over 12, then pi over 6, pi over 4, then pi over 3, negative pi over 12, negative pi over 6, negative pi over 4, and negative pi over 3. Okay, interesting. Now let's say the function looks something like so. Oops. Start at negative 3. And be a mirror image on either side of the y-axis. So what function is a mirror image on either side of the y-axis? Well, that would be cosine because he's an even function, right? But cosine usually starts where? At positive amplitude, or positive 1 if I didn't have an amplitude. But this guy's starting at negative amplitude, or negative 3. So if I start at a negative value, that must mean that I put a negative sign in front. Okay, why is this so difficult? I don't know. Okay, so I claim that this is cosine. I claim that this is cosine, but because he starts negative, I claim there's a negative because I'm starting down here. So what is the amplitude? I claim the amplitude is 3. And what is the number n I divide by? Well, let's take a look at this. This is not 2 pi over here. So let's multiply top and bottom by 2 to get 2 pi. So that would be 2 pi over 6. So it looks like the number I'm going for, 6, is n, because that's what I divide by, 2 pi by, in order to get pi over 3. So I know I'm negative, I'm cosine, my amplitude is 3, and that which I divide by is 6. So I claim that the function is going to be, what color should I use? What color did I use over there? I claim that the function will be cosine of, there'll be a negative in front, there'll be a 3 for the amplitude, there'll be a 6 for that which I have attached to theta inside the function. So there we are. This is our f of theta. Okay, so let me move this a bit closer to the function. There we go. So hopefully this is making sense to everybody, and I will see you guys in the next video.